Hello, good day everyone. So we are here for another topic for your hydraulics. Okay, this will be our last topic for your prelim for this course. So the next topic we're going to discuss is the continuation of your fundamentals of fluid flow. We're going to talk about your energy and the head. So dito pumapasok yung topic ninyo during your physics, which is your Bernoulli equation. So ano ba yung Bernoulli equation? Diba? Your Bernoulli equation is an energy equation which is relating to a work that is already done at a specific distance. No? If you ever remember your physics that the Bernoulli equation, you have there your velocity head, you have your pressure head, and you have your elevation head. And all of those heads, no, the unit that we are going to consider is in meters. No, but we know that energy is Newton times meters, no, kung energy yung kinukuha natin, which is the joules, no. So let us relate this one. Why is your Bernoulli equation or your energy equation, the unit will fall into meters. Okay? So, any fluid that has an energy possessing is pinopossess natin yung kinetic energy at yung potential energy ninyo. First, let us try to define what is kinetic energy. Kinetic energy is the ability of the fluid of mass to do work by virtue of its velocity. While your potential energy, the energy possessed by the fluid by the virtue of its position or elevation with respect to the datum or by the virtue of the pressure experienced by the fluid flow at that point. So actually, any substance or any fluids that tends to move or is flowing, meron tayong kino-consider dyan na kinetic energy and potential energy. Like for example na lang sa falls ninyo, no? Have you ever tried na pumunta doon sa falls ninyo kung saan nagsa-strike yung tubig, no? Nafi-feel nyo yung weight ng falls dito sa shoulder ninyo kung naranasan nyo yun. And that is because we have kinetic energy and potential energy. Okay, so let us talk about this head. The head is the amount of energy per pound or per newton of fluid. So, ibig sabihin, no, if your energy's formula is joules or that is newton times meter, your head daw, yung pag sinabi natin head, that is the ratio between your energy divided by the pounds. No, normally yung pounds natin that is weight, no? So, kung i-relation natin yan silang dalawa, as you can see, Newton here will be cancelled. Ibig sabihin, your energy equation, no, will fall sa unit of meters. That is why for your velocity head, pressure head, and elevation head, the unit that we are going to use is in meters. Okay? So, you have here, let us try to quantify what is kinetic energy. So, going back to your physics, we know that the formula of your kinetic energy, that is 1/2 of m times v squared, where your m, that is your mass, and your v, that is the velocity. Okay? Ke is equals to 1/2 weight over the gravity times v squared. Paano nangyari na yan? Because we all know that your weight is equals to mass times gravity. Okay, deriving the formula, therefore you will have weight is equals weight over grams, weight over the gravity is equals to mass. Okay, where your weight is in Newton and your velocity is in meters per second. Okay, that is for your kinetic energy. So how about for your kinetic head or your velocity head, no, which is your energy equation for the velocity. So that is just the ratio between your kinetic energy and your weight, excuse me. Because as a definition ng head na tinatawag natin kanina, head is different from the distance of the elevation. Okay? Pag sinabi natin velocity head, di ba, that should be energy divided by the weight. So, yung energy na pinag-uusapin natin sa kinetic head or velocity head, that is your kinetic energy. And we all know that your kinetic energy is Ke over W. And the unit for your Ke, that is Newton times meter. Well, the unit of your weight, that is in Newton. Cancel Newton, it will leave us meters for your velocity head. Okay, so we know that your kinetic energy, that is 1/2 W over G, V squared divided by W. So we know that your weight here can be cancelled. Ibig sabihin, it will leave us the value of your velocity head as V squared over 2G. Okay, velocity head, that is the speed of your fluid flow with respect to the datum na pagbabasihan natin. Next will be your potential energy formula. Okay, as a recap, the formula for your potential energy, that is mass times gravity times the height. Okay, again, we know that the value of your mass, that is weight over the gravity. So gravity here will be cancelled. Ibig sabihin, your potential energy, that is weight times the height. Okay? Kung pagbabasihan natin sa iyong Bernoulli equation, your height there or your head there is considered as variable z. That is why potential energy is also weight times z, or the head. PE is the potential energy in a unit of joules, which is Newton times meter. Weight is in Newton, and you have here your Z. If your elevation is above the datum, that is positive. If your elevation is below the datum line, therefore that is negative. Okay, if this is the datum ng inyong pipe na pagkakalagay, going upward, that is positive. The height downward, that is negative. Okay, so let us quantify the formula for your elevation head. Okay, pag sinabi natin elevation head, gaano nakaangat yung pipes ninyo or yung system ninyo from the datum. Okay, so since elevation head yan, that is an energy equation divided by the weight. So potential energy divided by the weight, that is WZ divided by W. W here will be cancelled. Therefore, your elevation head, okay, is equals to Z. Next is let us try to talk about, no, ito na pag-usapan natin kanina. Let us talk about your potential energy formula. Okay, I have this one. You have weight over the gravity times height. Okay, gravity here will be cancelled. Okay, so you will have potential energy times the weight. For a while, guys, ha. Okay, potential energy is equals to weight times the height. Okay, so since pressure head na yung hinahanap natin dito, we all know from your hydrostatic force that pressure is equals to gamma of H. When we derive the pressure formula in terms of height, we all know that height is equals to pressure over the gamma. And that is why you have this equation for your potential energy. Okay. P here, take note, your P here is gauge pressure in pascals. Meron tayong tatlong pressure na kino-consider. That is the absolute pressure, the gauge pressure, and the atmospheric pressure. So please take note that the pressure that we are talking here is a gauge pressure. Okay, so let us talk about your unit head. I mean, for your pressure head, that is the ratio between potential energy and the weight. So WH divided by H, now that we know that the value of your H is P over gamma. Cancel natin yung weight, therefore your pressure head is P over gamma. So we did discuss three types of head. You have your velocity head, your elevation head, and your pressure head. Your velocity head, that is V squared over 2G. Your elevation head, that is Z. Your pressure head, that is pressure over gamma. Gamma is the unit weight of the liquid. Okay, that is the thing na alam nyo na what is gamma. So this is the diagram na kinukuha natin. Okay, this is the datum I am referring about. Okay, if the distance or if the head we are talking is above the datum, therefore that is positive. If the head we are considering is below the datum, therefore that is negative. Okay, the total energy we are looking for, the total head we are looking for is this one. Okay, so Z, ay, mali, saan na napunta yun? Okay, so Z here is your elevation head, your P over gamma is your pressure head, and your V squared over 2G, that is your velocity head. So this one is your point 1, and this one is your point 2. If you are looking for your total energy and total height, that is just the summation of your kinetic energy plus your potential energy. So when you are looking for your total head, okay, that is just the summation of HV, which is your which is your velocity head, plus HP, which is your pressure head, plus HZ, which is your elevation head. Okay, so total, that is just V squared over 2G plus P over gamma plus Z. Or sa libro, no, mas kilala ito as a variable E. That is the total energy or total head of a specific problem. No? And take note that this formula, ang unit niya is in meters. Because napatunayan na natin kanina that energy divided by a specific pound of Newton, no? Cancel. Ibig sabihin, total energy head that is in meters. Okay? Mas kilala ito as total head or energy head. No? Pag sinabi natin, what is the energy head at point A? So, ito yung equation natin. What is the energy at point 1? Yan yung kukunin ninyo. Okay? So, let us establish yung sinasabi ko kanina, which is the Bernoullis energy theorem. Okay? Bernoullis energy theorem is any stream flowing steadily without friction. The total energy contained in a given mass is the same at every point in its path of flow. In other words, kinetic energy, energy of position, and pressure energy each be converted into either of the two terms theoretically without loss. Okay? So sabi natin kanina, this is your energy head or that is your total head, no? Which is velocity head plus pressure head plus elevation head. So when we're going to refer your point 1 is equals to point 2, ito yung magiging equation natin. That is just energy head at point 1 is equals to energy head at point 2. It's because the flow of our fluid is papasok siya from point 1, lalabas siya sa point 2 ninyo. And take note, this formula has no head losses. Okay? Pag sinabi nating no head loss, ibig sabihin the fluid we are trying to solve or the fluid flow that we're trying to solve is theoretical. Pag sinabi natin theoretical, those are the fluids that are ideal. Okay? If ideal fluids yung sinosolve natin, there is no friction. Kapag walang friction, ibig sabihin walang head loss. Okay? Kasi saka lang naman nangyayari yung head loss when there is energy dissipation. So, kailan ba nagkakaroon ng energy dissipation? When there is friction or meron tayong kino-consider na roughness, no, sa ating pipes, between the pipes and the fluid itself. Okay? Again, those fluids or those flows that has no head losses or no frictions, those fluids are ideal or theoretical value. That is why if you will try to equate the energy at point 1 at energy at point 2, no, that is just V1 squared over 2G plus P1 over gamma plus Z sub 1 is equals to V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. Okay, but what if we are going to consider head losses or head added? Okay, I want you to look at this equation muna. This equation. Okay, it's just the same, that is energy 1 is equals to energy 2. But in here, we are not talking about ideal fluids or theoretical value. No, I want you to look at this. If our fluid enters, no, if this valve or if this pipe is open, ibig sabihin, we are considering pressure head. Okay? If the velocity moves or flowing sa inyong pipe, ibig sabihin, there is velocity. Since nakaangat tayo dito, nagko-consider tayo ng velocity head. Since your pipe is at z distance or z head from the datum, therefore you have your energy, or I mean, you have your elevation head. Okay? So, since yung fluid ninyo is flowing inside your pipe, therefore, nagkikiskisan yung walls ng pipe ninyo as well as for your fluid. When the two particles is nagkikiskisan, ibig sabihin, there is head loss. No, from point 1, nagko-flow siya sa point ninyo, saka siya umabot sa point 2. So, ibig sabihin, saan nagsimula yung pagkiskis ng fluid at ng pipe ninyo? Sa point 1. Tama? When there is pagkiskis between the fluid and the pipe ninyo, ibig sabihin, there is friction. When there is friction, there is energy dissipation. Kapag may energy dissipation because of the friction, ibig sabihin, may head loss. Okay? So, that is why, as you can see here at the equation of your energy at point 1, we are considering negative head loss. Bakit negative yung head loss na kinoconsider natin dito? Kasi nga, nababawasan niya yung amount of energy ng isa buwan ninyo. Diba? Going back, head loss is the energy dissipated due to friction. Kaya meron tayong negative head loss sa point 1 ninyo. Kasi galing man sa point 1 yung pagkiskis ng fluid. That is why nandito yung head loss formula natin. And that is why minus kasi nabawasan niya yung energy. Okay, I hope I'm making sense. Okay? So, to better understand or to better as practice sa Bernoulli equation na pag-arrange ng formula ninyo, ililipat natin to on the other side of the equation, which is the same definition lang naman pa rin, no? So, from negative, ilipat natin on the right side of the equation, you will have positive HL. So, if you ever wonder kung gagamit kayo ng libro, sabi ni Ma'am Maya, ang value daw ng HL or ng head loss is negative. Bakit dito naging positive na? Lilipatan natin siya on the other side of the equation ninyo. Okay, at point 2, that is the end naman. So, dito, wala nang friction dito kasi end naman to ng flowing ninyo. So, itadagdag na natin yung head na nawala sa inyo. Okay, so this is your energy equation considering you have head losses. Let us try to solve an example para mas maintindihan nyo kung ano yung dinidiscuss natin. Okay, so at point A, at elevation of 200 in a pipeline, carrying a water, the diameter is in meters. The pressure is 100 kPa and the velocity is 1 meters per second. At point B, which is 2 meters higher than A, the diameter is 0.5. The pressure is 20 kPa. First is, let us try to find the head loss, the energy at B, the energy at C. Okay, so let us try to solve for your head loss. Okay, if this is your pipe, this is your point A and that is your point B. So from the datum, the elevation of your point A is 200 as stated sa problem. Okay, sabi niya naman dito at point B, that is 2 meters higher than A. So from the datum, papunta sa point B, ilan yun? That is 202. Okay, so as a solution, let us try. So you have 2 points here, no? Point A and point B. Hahanapin natin yung head loss. Hindi nyo naman magagamit yung major head losses ninyo dito, yung Darcy Weisbach, yung Mannings, and your Hazel Williams. It's because walang coefficient na nagamit dito or walang coefficient na binigay. Therefore, hindi nyo yun muna magagamit. Sakali nyo lang makukuha yung head loss ninyo using the Bernoulli equation. Okay? So, you will have this one, no? Equation 1 or energy 1 or energy at A is equals to energy at B plus D head loss. Okay? So, you will have here, I stated here that your discharge at A, let us say na lang ha, point A is 1 and point B is 2. Okay? point 1, the discharge at point 1 is equals to the discharge at point 2, which makes sense. Now, going back sa ating discussion last time, that is because of continuity principle. If what is the rate of the fluid that is going inside, that is also the rate that going outside, therefore the discharge is equals. Wala mong sinabi na nagbago, diba? What fluid enters, that is also the fluid that comes out. Ibig sabihin, that is just equal. Okay? So you have here, given that at point A, the diameter is 1 meter and the velocity is 1 meter per second. And at point B, you have a diameter of 0.5. So let us try to equate your Q sub 1 and your Q sub 2. Okay? So in that case, you have pi over 4, 1 squared times 1. Pi over 4 times 0.5 squared times the V2. Ibig sabihin, makukuha nyo yung velocity at point 2 ninyo. And that is equal to 4 meters per second. Okay? Velocity 1, that is 1. Pressure 1, it is stated na that is 100. Ito, 100 daw yung pressure. Elevation 1, that is from the datum papunta sa point A, therefore that is 200. So, velocity at point 2, kakasolve lang natin, which is 4. Pressure at point 2, given, that is 20. Z sub 2, that is the elevation from the datum papunta sa point 2, therefore that is 202. Okay, so this will be your equation looks like. Okay, so you will have one equation with one unknown, which is equals to head loss. So when you try to input that one to your calculator, no, kindly check if the value is 5.39 meters. No, naintindihan na natin bakit, even though energy equation yan, naintindihan na natin bakit ang unit natin for energy is in meters. Okay? So, can you confirm na lang if the value is 5.39? Okay? So, next is determine the total energy at point B. Pag sinabi natin total energy, that is just your velocity head plus pressure head plus the elevation head. Ganun lang. So, kanina na-solve natin yung value ng velocity ninyo as 4, no? The pressure is 20 divided by 2 times 9.81. This is the gravity. This is the unit weight density. That is 9.81 times or plus 202 rather. Kindly check, no? If that is 204.854. Sige, check natin. Okay, so you have 4 squared. Sige, sabayan nga ako. You have 4 squared times 2 times 9.81 plus 20 divided by 9.81 plus 202. And that is equals to 200.854. Mga vlogger ba? Okay, that is your energy at point B. How about for your energy at point A? No? Baka nagtataka kayo, bakit hindi natin sinali yung head loss? No, head loss is not included to your energy equation. No? When you remember on how we derive the energy equation kanina, walang head loss doon. Yung head loss dyan is dinagdag lang natin based on the based on the setup ng problem natin. Okay, pag energy lang, energy head lang or total energy yung hinahanap natin, ito lang yung equation na gagamitin ninyo. Okay, I hope I am making sense. Okay, so you will have 1 squared over 2 times 9.81 times 100 plus 100 over 9.81 plus 200. And that is equals to 210.24. That should be 245, no? Kung 3 decimal points tato. Okay? I hope I'm making sense. I hope naintindihan ninyo to. Okay? So let us try this one. Ayaw lumabas. Ayan na. Okay? So ito na yung formula na nakita ninyo during the first lesson for your fundamentals of fluid flow, which is for your nozzle. Okay? Pag sinabi nating nozzle, yan yung nilalagay natin sa hose ninyo. 'Di ba? Kapag naglagay tayo ng nozzle sa hose ninyo, ibig sabihin na ma-manipulate ninyo yung discharge ng fluid ninyo. Pwede niyong palaksan, pwede niyong pahinaan. 'Di ba? Yan yung use ng nozzle ninyo. Since sa nozzle ninyo is dumadaan yung tubig, nagta-touch yung tubig sa nozzle ninyo, therefore, meron ding head loss between the two. And the formula for that one, that is the velocity of the nozzle divided by squared divided by 2g times 1 over cv squared minus 1. Cv here is your coefficient of velocity. Okay? Let us try to answer this one. Okay? Sabi dito, an 80-meter rubber cotton lined hose having a diameter of 75 mm is attached to a hydrant at a pressure of 410 kPa during the flow. So assume that the hose is horizontal and the friction factor is 0.024. Friction factor to. Okay? At what rate will be discharged to the rubber to the cotton line hose? Ibig sabihin, at point A, okay, A pa yung hinahanap natin, hose pa lang yung pinag-uusapan ninyo. Wala pang nozzle dito. Hahanapin daw natin yung discharge na nanggaling sa hose ninyo. So, if this is your figure, ito yung hose ninyo, this is your point 1, and that is point 2. You have a pressure between your hydrant and your hose at P sub 1. Okay, the diameter of your hose is 75 mm diameter and the length of your hose is 180 meters. Hahanapin natin yung discharge. Using your energy equation, okay, you will have VA squared over 2G plus PA over gamma plus ZA is equals to VB squared over 2G plus PB over gamma plus ZB plus HL or plus the head loss. Okay? Dito, we will state that QA is equals to QB. That is because of the continuity flow. Velocity head is equals, velocity A is equals to velocity B. Since there is no there is no statement sa problem na from point 1, nag-iba yung velocity papunta niya sa point 2. Ibig sabihin, the flow of the fluid is equal. ZA, your elevation head is equal to the elevation B. Bakit? Pantay lang sila. No, as stated sa problem ninyo, your hose is in horizontal. So kapag horizontal sila, ibig sabihin their distance or their elevation head is equal. Gets? Okay. Having that said, no, you will have this equation. Okay, VA squared over 2G 410 kasi sinabi at point 1 there is pressure 1. 400 divided by 9.81 plus ZA is equals to VB. Actually, pwede na natin itong makancel kasi equal sila. ZA here will be also equal to ZB. So, cancel lang. So, pag-usapan natin, bakit 0 yung pressure head at point 2? Okay. Always remember, parehas ng sinabi ko sa inyo last time, that if your tank is open or if your fluid is open into the air, therefore the gauge pressure is equals to 0. Since at point 2, open naman ni ito kasi nagre-release or nagdi-discharge na yung tubig ninyo, therefore pressure is equals to 0. Okay, I hope I'm making sense. Intindihan nyo yan. Okay, so by making this formula, you will be having the value of your head loss. Therefore, head loss is equivalent to 41.79. Pero hindi yan yung tinatanong at problem letter A. Ang hinahanap natin is the discharge. Given that you have a head loss, given that you have a friction factor, anong gagamitin ninyo to get the discharge? Doon napapasok yung major losses natin due to friction, which is the Darcy, the Mannings, and the Hazen-Williams. So since friction factor man yung binigay or coefficient of friction rather yung binigay, matik, that is Darcy weighs back So that is 0.0826 FLQ squared divided by D raised to 5. Sabi natin head loss is 41.75. This is constant. This is your friction factor or your coefficient of friction. This is your length, which is 180 meters. This is the discharge, and this is the diameter. So 0.075 from millimeter, convert natin to meters. By doing that one, by using your calculator, can you check if the value is 0.016? And again, the unit for your discharge is in cubic meters per second. Okay, I hope I'm making sense so far. Okay, so let us proceed to your question letter B. Sabi niya, if 25 ml nozzle is attached to the hose, that would be expected head loss. Ulit. If 25 mm nozzle is attached to the hose, what would be the expected head loss if P is equals to 480 kPa at the hydrant is maintained? Let us use CV as 0.96. As you can see, yung hose ninyo, nilagyan na natin ng nozzle. And according sa principle natin kanina, kapag gumamit tayo ng nozzle, may head loss din tayo nakukuha sa nozzle itself. Kasi bakit? May friction between sa nozzle at sa fluid ninyo. No, may friction. Kapag may friction, may head loss. Okay? So this will be the equation that we are going to consider, which is just the same, no? Dahil sinabi natin, because of the continuity flow, no, what fluid comes in, that is also the fluid comes out, therefore that is equal. No, magmamatter na lang tayo dito sa velocity ninyo. Kasi sabi ko kanina, kapag nozzle, pwede niyang mamanipulate yung lakas ng pagbuga ng tubig ninyo or yung speed ng paglabas ng tubig ninyo. Diba sabi ko sa inyo during our face-to-face class, even if lumiit mo yung diameter, but the flow of the fluid at a specific time is equal, therefore, papasok pa rin yan siya sa continuity flow ninyo. Having that said, QA is equals to QB. Yung B natin is considering dito na sa nozzle ninyo. Okay? That is just pi over 4 times the diameter of the hose VA is equals to the area of your nozzle times VB. Okay? So, simplifying that one, no, kung gusto yun natin in terms of VB tayo, that would be equal to 9 VA. Anong gagawin ninyo? You will just divide both sides by this value. So, 4.418 times 10 raised to negative 3 divided by 4.908 times 10 raised to negative 4, and you will be having this value. Okay, algebra lang. So, head loss, dalawang head loss na yung kinoconsider natin, which is the head loss of the hose plus head loss of the nozzle. So, you will have FLV squared over D2G plus VN squared over 2G times 1 CV squared minus 1. Okay, sis, in this case, hindi pa ninyo alam what would be the value of your velocity. No? Ma'am, pwede naman po, 'di ba, nakuha naman po natin yung head loss ng hose kanina. Pwede po ba namin gamitin yung value nun? Yes, pwede naman. But it will not make sense kasi kailangan natin kunin yung value ng VB at VA ninyo to solve for this one. Okay? So, simplifying the equation, you will have this value, no? Itong 2.936 nanggaling to dito. Okay, kindly use your calculator. Kindly check that one. And for, what is that VA lang lahat? Okay, so try natin. So you have 0.024 times 180 divided by 0.075 times 2 times 9.81. That is 2.936. Okay, that is for VA. How about for the other one? So you will have 2 times 9.81, 1 over 0.96 squared minus 1. 4.333. Okay? Okay, so have you ever checked if tama yung value nito? If the answer is yes, yes, tama to. Okay, so kung ito naman, isa-solve nyo naman yung values nito, I think hindi nyo makukuha itong 0.951. It's because hindi nyo talaga makukuha yan. Kasi in terms natin, yung equation by VA. Bakit? Tingnan nyo to. Ay, nawala. Paano nyo tingnan? Okay, we know, no? We know that the value of your VB that is equals to 9 VA. Okay, so you need to transpose the value of your VB that would be 9 VA of squared. Okay, so input nyo nga, parehas lang pa rin yung value. 9VA squared divided by 2G times ito. And I think you will fall to the same value of 0.351. And this is no longer VA. This is no longer VA kasi pinalitan mo na yung value ng VEB by 9VA. Therefore, you have 0.351 VA squared. I hope I am making sense. Okay? Therefore, to conclude, you have head loss is equals to 3.287 times VA squared. No? Ibig sabihin, makukuha lang natin yung value ng head loss ninyo na tinatanong sa letter B if malalaman natin kung ano yung value ng velocity at point A ninyo. Now, this is a very long process, no? But this is very easy kasi process nga lang siya, no? Okay, so ito na yung na-solve natin a while ago. So using your equilibrium equation, your Bernoulli equation, okay? So this is your energy at point 1, energy at point 2, plus the value of your head loss. Alam natin, this is equal. Bakit mali yung ating na-cancel? Ulit. No? ZA is equals to ZB. 0, okay? 0 ang pressure at point B because that is open to the air. If the pressure is open to the air, therefore the pressure is 0. So, ilan yan? Makukuha ninyo as a value of your VA. Okay? So, kindly check na lang, using your calculator, your VA will fall to the value of 2.578 meters per second. Okay? That being said, if nakuha na natin yung head loss ninyo, ay yung velocity A ninyo, makukuha na din ninyo yung velocity at point B, which is equals to 23.202 meters per second. But the problem is, hindi naman yan yung tinatanong. Ang tinatanong sa atin is your head loss. Okay? You can use the longer equation na nagamit natin or you can use 3.287 VA squared. Okay? And you will fall to an answer of 21.85 meters. Check na natin. 3.287 times 2.578 squared, and that is equal to 21.846 meters. No, or that kung to decimal, that is 21.85 meters. Okay, so for the discharge for question letter C, discharge given by the nozzle. Okay, so since nozzle na yung pinag-uusapan natin, di ba the formula of your discharge is area times the velocity. Balikan natin yung problem. Okay, sana yun? Ito oh. Sige. Dito sabi sa problem, okay, sabi sa problem that, sige, medyo naglalag pa yung ating ano. Sabi, medyo naglalag ko talaga. Sige lang. Ayun. Sige, balikan natin yung problem natin. Sabi sa problem letter B, no, that your nozzle is being attached sa iyong hose, which is at the diameter of 25 ml. Kung kukunin natin yung discharge dito sa nozzle ninyo, that is area times the velocity. Meron tayong dalawang velocity, which is velocity at point A and velocity at point B. Question, anong velocity yung gagamitin natin? Is it sa A or sa B? The answer would be sa B, which is the velocity galing sa nozzle ninyo. Huwag kayong malito dyan. Okay? So, therefore, the velocity that we are going to use is 23.202, and that is equal to 0.0114 cubic meters per seconds. Okay? If you have any question, no, don't hesitate to visit me sa faculty or chat me na lang, no? Open naman yung messenger natin for your questions. Okay, moving on to another fundamentals of fluid flow, no, which is talking about for your energy equation pa rin, you have here your pump. Okay? Pump is basically used to increase the head ninyo or yung height ninyo. No, normally yung pump is ginagamit natin, or I mean, usually yung pump is ginagamit natin to raise water from the lower elevation papunta sa taas. No? That is because of the tanke, or minsan yung tubig ninyo is hindi na maabot sa second floor, sa third floor. It's because wala ng energy or wala ng pressure na tumataas sa tubig. So, ginagamit ninyo yung pump. Okay? And the thing that you need to know kapag pump yung pinag-uusapan natin, that is head added. Bakit head added? Kasi dinadagdagan natin yung height ng fluid ninyo by pumping it one. No, it is basically used to increase the head. Dinadagdagan natin yung head energy ninyo. So kapag pump yung pinag-uusapan natin, that is head added or HA. Okay? So the input power, yeah, for a while. Sige, pakita. Wait lang ha. Gawas lang mo halaga. Okay? So, sorry for that, no? So, the input power for pump of the pump, that is your electrical energy. So, kaya nagre-raise or nag-i-increase or tumataas yung tubig ninyo, that is because of the input power sa pump ninyo, because of the electric. And the power output or your P out is the flow of energy. So, since kinukuha natin yung efficiency ng pump ninyo, always remember that the energy na nakukuha natin sa pump is the output. I mean, the power that we are getting kapag pump yung pinag-uusapan natin, that is output. Output power. Remember that ha? Pag pump, that is output power. Okay? So, ano pa ba? You have here your turbine, no? Nag-help din yan sa pag-flow ng fluid natin. A turbine or motor extract flow energy to do mechanical work, which is converted to electrical energy of turbines. Okay? So, pag sinabi nating turbine, that is head extracted. Bakit head extracted? It's because yung turbine is ini-extract natin yung energy or yung ginagamit natin yung energy to convert the energy para maging power. Okay, like for example, sa Maria Cristina Falls, no? 'Di ba yung energy na yon, kino-convert niya para maging electric or para maging kuryente, no? I'm not updated if yun pa rin ba yung ano ng basta yung sa Maria Cristina Falls, na if you will remember your elementary days, no? So yun kapag turbine, yung energy naman is di talaga siya nawawala, no? But it can be convertible, no? Yung energy, kino-convert natin siya para maging electric. At yun yung ginagawa ng turbine ninyo. Ibig sabihin, nag-e-extract tayo ng energy. Kapag nag-e-extract tayo ng energy, binabawasan nyo yung energy ninyo. That is why you have head extracted. So you need to remember, HA, head extract, ay ano ba yan? HA, no, from pump is not equals to your HE. Okay, HA is head added, that is plus, while your head extracted, that is minus. Okay, head added is for the pump, head extracted is for the turbine. Okay? So, since negative yan, lipat lang natin ulit on the other side of the equation para sa ginawa natin sa head loss. Therefore, you will have this equation. The same meaning lang naman pa rin tong dalawang ito. Okay? At kapag turbine yung pinag-uusapan natin, no, the power it gives, no, yung power na binibigay ng turbine ninyo is input. Okay? Pag-usapan naman natin to. Power. Yan yung power na sinasabi ko pa kanina, no? Power is the rate at which work is done. No, kapag natapos na yung work. Yan yung tinatawag natin na energy, na power. So the formula for your power, that is gamma Q times E. Your E there is the energy. So ang power ninyo is nakadepende if pump or turbine yung sinosolve ninyo. Okay? If pump yung sinosolve ninyo, the output or the power you are going to use is gamma Q. As you can see, the energy, that is HA. Because again, pump is head added and the power it produces is power out. Okay? You have here the efficiency of your pump, no? Yung usefulness ng pump ninyo, that is a formula of power out divided by the P in times 100. So always remember, pag pump, output power ang binibigay nito. And that is in a formula of gamma Q H A. Okay? For the turbine naman, sabi ko ang power na binibigay ng turbine ninyo is input power. And that is in a formula of gamma Q times HE. Your energy is HE. Since it is turbine, that is head extracted. So, same formula for the efficiency. Ang pinagkaiba lang, pag pump, that is output. Pag turbine, that is input. So, para hindi nyo makalimutan kung ano yung efficiency ng dalawang ito, remember nyo lang yung POTI. Bakit POTI? Pump is output, turbine is input. Okay, pag tatanungin kayo, anong power yung binibigay ng pump? Madali lang yan, POTI o pump is output. Anong power yung binibigay ng turbine? POTI. Turbine input. No, so that is power in, that is power input. Okay, I hope I'm making sense. So let us try to have this example. Okay, a specific gravity of 1.26 is being in a pipeline from point A and point B. The diameter at point A is 600 and the pressure is 300 kPa. At pipeline B, this one, now the diameter is 300 millimeters and the pressure is 330. Point B is 1 meter lower than point A. If the pump puts 16 kilowatts into the flow and neglecting the head losses, determine the discharge. Okay, this is your figure. Due to continuity flow, let us say your QA is equals to QB. Okay, so you have your Bernoulli equation. You have HA dito. HA tayo. HA, it's because head added because of the pump. Okay, let us have here for your A, since the diameter is 600, so that is 0.6 squared. So in terms of velocity, okay, kasi velocity man yung nasa energy equation natin, that would be 3.352 squared. IQ, rather. No? Divide nyo lang to. No? That is, no? Algebra lang. Okay? So, having that said, sana galing tong 14, ganun lang pa rin. Ano ba yung nangyari? That is just Q is equals to the area over velocity. Gusto nyo makuha yung velocity, therefore divide both sides by the area. Okay, area will be cancelled. Makukuha nyo yung value ng velocity ninyo. Okay? So this is your velocity head. This is your pressure head. This is your elevation. Okay? Or your elevation head, HA, your velocity head, your pressure head, and your elevation at point B plus the head loss. Bakit ganito? Pag-usapan natin yung inyong ito. the elevations ninyo. Okay, ganito kasi yan. From point A, if this is the datum natin sa point B, from point A papunta sa point B, the distance is 1. Tama ba? So from point B papunta sa point B, that is 0. Kasi yung datum na binasihan natin dito is at point B. Therefore, the elevation at point B is 0. Okay? So, using your power energy, that is gamma QE, and the energy natin is head added. Kasi pump man tayo. This one is for the turbine, pero hindi natin yan kailangan. Ito yung kailangan natin. Okay? So, deriving the formula, no? Alam natin that your power is equal to 16 watts. Your Q is the discharge times 9.81 times 1.26. That is converting water to the new substance na binigay ng problem by multiplying that one to the specific gravity multiplied by the HA. So since dito, no, anon yung Q, anon pa talaga yung HA. So let us try to in terms HA by Q. Okay? So that is just 9.81. 9.81 in terms of Q tayo, 'di ba? In terms of HA. So that is 16 divided by Q times 9.81 times 1.26. It will be equal to 129 times Q. Subukan niya lang, no? Divide both sides by this value para in terms of HA tayo. So that is 16 divided by Q times 9.81 times 1.26, and you will be having 1.29 over Q. Okay? Yan yun. Ito na yung magiging value ng HA natin. Okay? Therefore, the value of your Q is 0.418. Bakit ganon? Ma'am, di mo pa man nakuha yung head loss. Bakit ka na nag-come up sa value ng Q as 0.418? Balikan niyo yung problem. Ano ba yung sinabi ng problem? Neglect head loss. Ibig sabihin, this one is eliminated. No? By that case, our equation is in terms of one unknown, which is the discharge. Okay? So, since nakuha na natin yung value ng discharge ninyo, pwede na ba natin makuha yung value ng head added ninyo? Pwede. No? Because we all know that head added is equals to 1.29 over Q. And that is equals to 1.218, 1.29 divided by 0.419, and that is equal to 3.09 meters. Okay, letter C, input HP. If E is 80%, if the efficiency is 80%. Okay, so take note of this, the formula for your HP or horsepower, that is Q gamma of energy, since we know that that is power over 746 kasi, but we know that your energy is HA, that is why you have like this, divided by 746. So yung Q, that is 0.418, gamma is 9,810 times 1.26. This is in terms of Newton. Okay, kaya 9,000 tayo. Times the value of your HA, which is 3.09 divided by 746. And you have here, HP is equals to 21.408. And take note, naglagay ako dito ng output. Bakit output? Because we know na kapag pump yung ginamit natin sa pipe system ninyo, the power na binibigay nito is an output power. POTI. Pump output. Okay? So when kukunin nyo yung efficiency nito, no, that is out over in times 100, no? So, kung kunin yung input value nito, that is just 80% is equal to 21.40 divided by the input power times 100. I hope I'm making sense kung bakit output yung ating value ng HP ninyo. Okay? Because that is the energy of flow. P in is the electrical, no, energy. P P out is the energy of flow. Energy of flow mo yung sinasolve natin. Diba? So therefore, you have P out, you have pump output for the efficiency. And your input power, that is 26.75 HP. I hope I'm making sense. Okay? Sorry for this diagram lang, no? Eh, nahihirapan ako kung paano i-connect tong reservoir sa turbine. But please be consider na lang no, kung bakit ganito yung itsura niya. So we have two reservoirs daw. You have two reservoirs and the elevation of your first reservoir is 250 meters. Okay? The elevation of your second reservoir is 150 below from the first reservoir, which is that is 100. So the difference between the elevation is 100. 15. So sorry for this one, no? Sige lang. So given that you have your Hazen coefficient as 120, you have a discharge of 150 liters per second, and you have a length of 150. Okay? So first, let us try to get the head loss. Okay? This is your head loss formula. Since Hazen-Williams man yung binigay, therefore, this is the formula. No, Hazen coefficient yung binigay. The length is 100 and you have this one 0.15 as your Q. Since naka-liters man to, convert that one to cubic meters per second. Okay, and we all know that the 1 cubic meter is equals to 1,000 liters. And kali add na lang pala the value of your diameter, which is 0.25 meters. Okay? Ganyan lang. Gusto ko lang kasi makita paano nyo i-solve yung turbine. Therefore, your head loss is 3.89 meters. For letter B is let us try to solve for the value of your head extracted. Okay? Head extracted tayo dito. Bakit puro zero yung nakikita nyo dito? Okay? Why does the velocity head and the pressure head for point A and point B is 0. Ganito yung isipin nyo. Since reservoir or dam yung sinusolve natin, the velocity of the flow of your fluid is negligible. Kasi sa sobrang lawak ng sinusolve ninyo, kinukuhaan ninyo ng velocity, may hirap kunan yun. No? Kasi sobrang lawak. Like for example na lang, balikan nyo yung dagat. Yung dagat is, hindi naman uniform yung flow ng dagat ninyo. 'Di ba? Sobrang hirap kunin yung velocity ng dagat ninyo kasi paiba-iba siya. So that is why sa bigger area, sa malaking area or sa malaking storage ng fluid ninyo, dinidisregard natin or the velocity is negligible. That is why your velocity head is 0. Okay? While, on the other hand, bakit yung pressure natin is also equals to 0? If you remember, no, sa sinabi ko kanina, if your fluid is open to the air, therefore your gauge pressure is equals to 0. Or if your fluid is open to the atmospheric, ibig sabihin that is 0. So since reservoir man ito, open sa air, therefore the pressure is equal to 0. Sana nagme-make sense yon. Okay? So how about for your elevation head? Sabi natin dito, your ZA is equals to 150. So from point A, if the datum is your point B, the distance is 150. So if your datum is point B, papunta sa point B, that is 0. Okay? And plus HE or plus your head extracted plus the head loss, nakakasolve lang natin bago lang, no? It will fall to an answer of 146.11 meters. Okay? So let us try to get the value of your power daw. So power is equals to gamma Q times E. So since turbine to, the energy is HE. So that is just 0.15 times 9.81 times the head extracted. Therefore, power is equals to 215 kilowatts. Okay? That is 15 kilowatts. But if hahanapin pa yung output efficiency, you all know na efficiency is equals to output over input times 1,000. Ano yung power na binibigay ng turbine? That is input. Ibig sabihin kung magsasolve kayo ng efficiency, output power yung makukuha ninyo. And that is our discussion for this prelim ninyo. Okay? So I hope I'm making sense by doing this video lecture. So if you have any concern, any clarification about the last topic, you may consult sa akin dito sa faculty or you can PM me anytime. Okay? I'll try to explain what happened in a specific problem. So, yun lang. God bless everyone and thank you for listening.